How knowledge graphs make data unification affordable. I'm your host, moderator, and co-presenter, Mike Grove. Before we start, I just wanted to go over a couple housekeeping notes. If you're experiencing any audio or technical issues, please try logging out and then logging back in. You can also dial into the webinar by phone, rather than through the computer, for audio purposes. This webinar is being recorded, and a copy of it, along with the slides, will be sent to you within 48 hours. We encourage you to ask questions during the webinar. There's a Q&A button at the bottom of the window to submit your questions. However, we'll be holding off on answering them until after the presentation is finished, but we'll be sure to leave plenty of time for the answers. Let's quickly go over the agenda for today. After we wrap up our quick introductions, I want to provide a short overview of the problem as we see it and briefly describe why Stardog is the right solution. Then we'll focus on a demonstration of how Stardog breaks down the walls of silos within the enterprise and the kind of things connecting the data across your organization that this can unlock. With the remaining time, we'll do some Q&A. And now, our speakers. Again, my name is Mike Grove, and my background spans more than 15 years of experience in AI, semantic technology, and graph databases. Prior to Stardog, I performed research on the use of graph-based technologies in pervasive computing environments while at Fujitsu Labs of America. With me today is Amin Mirdamati, Director of Solutions Engineering here at Stardog. Amin has a diverse experience ranging from software development, pre-sales engineering, and product management. Prior to Stardog, Amin spent a lot of time working in the data and analytics space. And with that, let's get started. Data rules the world. Every big enterprise is awash in data, and they have big dreams about how it can be used. After all, it's the enterprise's most important strategic asset. Projects are planned and are being executed. Legions of data scientists, armed with SciPy and R, are ready to be unleashed. And all of this with the aim of effectively leveraging this asset. Enterprises are excited about all the possibilities their data unlocks. In the financial world, they're creating comprehensive data sets to aid in anti-money laundering or automatic regulatory compliance. In healthcare and life sciences, they're building data sets necessary to better understand and combat disease. Commercial enterprises are building Customer 360 applications to better understand and monetize their customers. They're counting on those data scientists to use all of their data to tell them what people are going to buy before those people even know they're going to buy it. Becoming a data-driven enterprise is the destination for these organizations, and data is the fuel that will get them there. The challenge is that historically, enterprises have had a very short-term focused view of how their data ecosystem is constructed, if they even thought about it at all. Business problems were identified and described, and infrastructure was built to support the specific solution to that problem. There's obviously nothing wrong with solving problems, but this approach is very organic. These systems grow up around lines of business and for specific purposes. Again, with very little regard to how they fit into the overall data landscape. So over time, you end up with this highly fragmented enterprise landscape that we see today, where all of an organization's data is stored in virtually every technology, locked away in silos, and unable to be effectively utilized. So what is it that these enterprises envision? Their ideal world is this pristine landscape of beautifully cataloged and accessible data. Everything that they could need for any of their use cases, from Customer 360 to AML, all of their data readily at their fingertips. They would have that single logical place to go to get all the data they need. They very much envision it like data as a service, providing the backbone or the foundation of their enterprise. Unfortunately, the reality in the enterprise is messy. The highly siloed enterprise data landscape is difficult to overcome, and none of our attempts to have effectively addressed any of the problems. We've been trying to put together data in meaningful ways using legions of ETL developers, making copies upon copies of data, oftentimes one for each use case. And we end up drowning in copies of that data. And along the way, we find ourselves with 18 copies of the same data set, and we don't know which one's the golden source. We try the boil the ocean MDM approach, and after 2 years, we realize we're at less than 0% complete. We set up bigger and bigger data warehouses, only to realize that they're impossible to extend for new use cases or new types of data. And in the end, we've just created another data silo. We make the fundamental mistake with data lakes and assume that co-location is unification. So we dump all of our data into a pile and wonder why the result isn't a clean, unified data set. And then we wonder why our data scientists end up doing lots of ad hoc data unification instead of doing actual data science. This reality leads us to our central point, that unconnected data is a liability. The common theme of the vision that enterprises have for their data-driven organization that they're trying to become is access to all of the relevant data. When data is fragmented in silos across the enterprise, it makes the kind of horizontal, cross-cutting access to that data that these organizations need nearly impossible. This prevents them from capably meeting their goals, and that is the liability. So what the enterprise needs is something that recognizes and leverages the connections and connectedness of their data, something that unifies it across the organization, regardless of where it is or what it looks like. What the enterprise does not need is a simple graph database, and certainly not another data silo. The enterprise knowledge graph provides a flexible and reusable foundation for the enterprise data ecosystem and makes it easy to add new data sources and connect more data silos as new use cases come up. It is an accretive system, taking advantage of the network effect of having more data and more connections as the corpus of knowledge grows. Is needed to create, curate, and operationalize knowledge. Here we see the definition of knowledge. The key part of this definition is, at the end, the sum of what is known. Earlier, we talked about the liability that comes from having disconnected data, from having that incomplete view of the world. The fragmentation of that data makes it nearly impossible to utilize the sum of what is known. An enterprise knowledge graph is about bringing all the data together in a meaningful way to create knowledge. The value proposition of the knowledge graph is that all data, data sources, and databases, everything that has data, is represented and operationalized by the knowledge graph. To accomplish this, Stardog combines a state-of-the-art graph database with the knowledge toolkit. This toolkit is what makes it possible to build the corpus of knowledge within your organization and avoid creating a graph-shaped data silo. The foundation of that is the logical data model. The knowledge graph provides the appropriate abstraction for the knowledge of your enterprise, and as such, it speaks the language of your organization. That is not rows and columns, or keys and values, or even nodes and edges. It's people, purchases, products, transactions, processes, servers, applications, patients, and students. Knowledge graphs are about knowledge. The connections in the data mean something, and the knowledge graph captures and represents that. Next, virtual graphs and unstructured content. The knowledge graph needs to operationalize all data. And there's a lot of data variety out there. So virtual graphs are needed, as well as handling for all of the unstructured data within the enterprise, such as text or images. That way, it can represent and make available all of the data across the enterprise data landscape. Peter Norvig once said that more data beats clever algorithms, and as a corollary, better data beats more data. So the knowledge graph needs integrity constraints, so it has the ability to represent and enforce data quality constraints so that you can create and keep better data. And finally, machine learning should be tightly integrated into the whole. It benefits from using the most comprehensive accurate, and up-to-date data to train models. So having it built into the knowledge graph so those clever algorithms can take advantage of more, better data will yield dramatically better results. And best yet, since it's a part of the knowledge graph, those models are operational and ready to use as soon as they are trained. Now that we've gone over the primary components of the enterprise knowledge graph, I'd like to go quickly over the architecture of the Stardog platform before we get into the demo. The key to the diagram here is that Stardog is the unifying layer for your data. It sits between the data and the folks who need it to provide the appropriate abstraction, again, to leverage that logical data model and bring together all of the data in the organization. To date, data consumers have had to deal with the reality of the enterprise data landscape themselves. They've had to make trade-offs when working on their projects. They accept out-of-date data or incomplete data because that's what's in the warehouse or mart that they have access to. They do ad hoc data unification by hand, oftentimes duplicating the work of others to build a custom, one-time only use data set. Or they get stuck waiting on someone to build them a new data product for their use case. It doesn't have to be that way anymore. The Stardog Knowledge Graph provides the data consumers with that single, coherent view of the data, the knowledge within the organization, forming the backbone of the modern data-driven enterprise. And that foundation serves as the basis for all the analytics and applications, from Customer 360 to AML, that these enterprises want to build. Now let's dig into Stardog itself. I'm going to hand over the show to our Director of Solutions, Amin, who will take us on a tour of the Stardog Enterprise Knowledge Graph. Amin, take it away.
All right, thank you, Mike. All right, so let's jump into the live demo. Now, today we're going to be looking at the knowledge graph in action and specifically focusing on some of the key capabilities of the knowledge toolkit as a whole. This includes some of the virtual graphs, how do we access data, how we build the data models, some business logic, and ultimately how do we get some value out of this. Now we do have a whole piece inside of the engine around machine learning. We will not be covering that on today's demo. We'll very likely have some other sessions where we can dive deeper into that, or feel free to get in contact with us and we can talk to you about some of those tools. Now, today's focus is around breaking down data silos. So we're going to be looking at different types of data from different data sources. Now, I know all of you probably work in different industries, have different data problems, and ultimately have different business issues that you would like to solve. So today we're going to be focused on some very generic movie data. Now, our data is going to be coming from about 4 main sources, pulled into Stardog and queried. Now, our first one is going to be IMDb. This has all of our movie information, so movies, the actors within them, the directors, production companies, etc. We also have information from Netflix. This is again going to pull in some more movie information, but we're also going to start including things like some of the user reviews. So as people logged into Netflix, they give it a 1 to 5 stars, choosing how much they like the movie. And we're also going to join this to critic reviews. Now, the interesting thing about these critic reviews is that these are just plain text. These are pieces that critics have written about movies, and we're going to actually pull in the metadata. We're going to actually do some text extraction, understand some of the entities inside of the text, whether they're referring to movies, to actors, to different types of performances, and also do some things like sentiment analysis on top of it. We're going to pull all of this into Stardog and also join it in with some Wikidata. Wikidata is the graph model of some of the Wikipedia information and allows us again to enhance some of the data. So for example, if we have a movie and it's shot in Hollywood, California, we can look up things about Hollywood, California very, very easily. Now this is all the data I already have loaded into Stardog. I do have that box office piece there at the bottom. We're going to come back to that in a minute. So what does this data look like? Now, there's a few ways to visualize this. We're going to first take a look at a third-party visualization tool called Linkurious. This is a nice tool for visualizing your graph, doing some exploratory analysis, and diving into the data. So we're going to start with a very well-known actor, Tom Hanks. Where's my cursor here? I've already done a search, and we have Tom Hanks up here on the screen. So being a graph, we see Tom Hanks. We have actually 42 different pieces about him. I'm going to click on it, and it's going to expand about every fact and relationship we know about Tom Hanks. So we see here in our data set every movie that he was an actor of, and we see a few different colored relationships as well. We see one of them here that he was an author and director of Larry Crowne, and same with That Thing You Do. So we start seeing a few additional relationships. Now let's dive into one of these movies. So let's take a look at, let's say, Toy Story 2. Here we go. That's what I was looking for. I'm going to drag this out to the side so we can just see this on its own. And I'm going to double click on it, and we're going to see everything we have about Toy Story 2. All right, so now we're expanding what we're looking at. So Toy Story 2 has a whole set of reviews associated with it. This is basically, we're doing a little bit of extraction for the title, everything that's blue and yellow, or review. And then we have things like, here's our author, we have like our directors, we have John Cusack as far as some of the other actors, and we can start seeing some of these relationships. So for example, there's Pixar and Walt Disney are the production houses, and not only have they produced Toy Story 2, but also the rest of the Toy Stories trilogy, along with Saving Mr. Banks, that all included Tom Hanks. Now, what I want you to understand from this piece is less about how do we traverse from one to the next, but understanding the form of the data that we have. Every time we bring in a new relationship, a new piece of data, this is integrated into our knowledge graph. So if in Toy Story 2 I've added in some of this box office data, which we will do later, I'd have a node here so I can see the revenue, not only in the US, but overseas, in each region. I can also bring in location, shooting location, but we're basically building up this universal model that defines all of our data and how it ties to each other. Okay, so from there, let's jump into actually using Stardog Studio to do some queries and start really seeing some of the power under the covers. So what we're going to jump into is Stardog Studio. This is one of our tools to help manage your databases. You can query your databases, load some data, manage security, see your queries running, and write Sparkle queries down here. Now Sparkle is a query language, much like SQL, with a little bit different syntax depending on what we're creating. Here I actually have a existing query in there. Let me just look at a very simple one and paste it in. And in addition to Sparkle, we also do support the Gremlin programming language and GraphQL. So you have a variety of different ways to access this data and work with Stardog. In Studio today, we are going to be primarily focused on Sparkle queries. All right, so our first one I'm loading in here is actually a text search on the word Tom. So we're going to try to get back to some of that same data we were just looking at in Link Curious. I'll click on Execute, and we actually have a fully indexed text search. This is going across every piece of data that we have inside of Stardog or in this database. And here I see a bunch of different actors. So Tom Selleck, Tom Wolfe, Tom Bauer, etc. Now these are all people. Now actually I can work on this thing for a second. Let me requery this real quick. There we go. So we can just make that as all people. But it's not just people we're looking at. If I actually sort this, we see that we have things, we have movies, organizations, we have different locations. This is literally across every piece of data in our database that includes the word Tom. Now, I know that the Tom I'm looking for here, let's actually make it into a query around Tom Hanks's movies. So again, I have an existing query already set up for myself here, looking for everywhere it's called Tom Hanks. Let's look for the actor Tom Hanks and pull back every movie that he is an actor in. Perfect. Run the query, it comes back and we have all of our results. So there's 42 in all. We're looking at top 5. We can customize that to see how many we want to look at one time. All right. So that's a relatively simple query. We're querying just the data we're getting back from IMDb, and we're looking at how many movies Tom Hanks is an actor. So that's not too complex. Most any tool can do this. Let's start bringing in the other data sources to start understanding those movies across different data sources. So I'm going to go back in here. I have another query where we can still not only bring in his movies, but let's pull in some of the rankings. We're going to pull in data from IMDb. We'll get the rating in there that's done by users. We'll get the Netflix ratings. And let's also do some of that unstructured data that we had in the critic reviews. So I have a query. It's a little bit longer here. There's a lot of white space in here, so it's not really actually that bad. But defining what I want to pull back, how I want this joined, click on execute, and we're going to be able to get one query that pulls from all those data sources. And we're able to see the average critic sentiment score, the IMDb user rating, and the average Netflix rating. So in one query, again, now we're actually breaking down some of those different silos. We're not only accessing the structured data where we have users giving a 1 through 10 score or 1 through 5 score. Actually, we have normalized this all to a 1 through 10 scale. But also some of the unstructured analysis, pulling those unstructured critic reviews and giving it sentiment score based on those results. And we can start seeing a correlation between these two. We start seeing that as the IMDb user rating and the Netflix rating, higher is better, obviously, and they seem to go in pretty close to lockstep. Now, Joe vs. Volcano happens to have a very different mix here, but not always does the user rating and the critic rating match up. Sometimes there's highly critically acclaimed movies that people don't like as much, or horribly critically acclaimed movies that really just somehow become a cult classic as users watch them. But again, what I want to drive home here is that we have one query, and we're pulling not only different data sources, but we're querying different data types all into one set of results. Okay, so now this is data that I have already loaded into Stardog. Let's take it one step further. So in our Knowledge Toolkit, we also have the ability to use what we call virtual graphs. Now, the data that we had in that slide before was my box office revenue data. This data, I have it in MySQL database, and I'm going to access this through what we call a virtual graph. This could be hypothetically high velocity data that's changing quite rapidly. I want it to be live and not stale in my graph. Or it just might be a lot of data that I don't want to have to pull and replicate or ETL into Stardog. We can map this and use this to enhance everything that we know inside of Stardog while leaving the data in place. Stardog will actually federate queries and pull back only the data it needs on the fly. So again, a little bit of background here. Our virtual graph, this is our table we'll be looking at. It has the movie name, year, country. We have a country code and the gross revenue in each of those locations. So if we take a look at this piece here, what we originally had is just this. We had the movie, the title, the year, and of course tacked onto this was information around actors, producers, etc. So we're going to use what's called R2RML to map these things together. We're going to say the column country name is actually region name in our graph associated to that. Gross is box office. Country code is a region code. But just by setting up that mapping, we're able to integrate all of this data into our knowledge graph. A quick example would look like this. We have a movie. It was released in 2016. In the US box office, it has a gross of $2,376,000. But what's nice is that it's not just that. This actually grows as we incorporate data. Not only do we have the US box office data, but we can break it down by region. We can look at this globally, or anything that we need based on our queries. just by mapping in this new set of data. So let's actually do this. So I'm going to go over here into, I have Visual Studio Code is my preference here. I have our R2 RML mapping. Now, Stardog does have some tools to help generate this based on your column names, table names, etc. Now, we've done some of this, the mapping here as well. So I see that my region code maps to country code. Region name is country name. Box office is gross. Now, to bring this in, we just have one line that we need to add in. So I'm actually going to copy and paste this. So I have this here. My terminal is down below. Click on enter. And I've added that mapping. Now I've included a properties that include my connection information to the database. This boxoffice.ttl is the file that we're looking at, and we're good to go. With that simple command, we're now able to actually run queries and pull that box office data into NALR results. So let's keep it simple. I'm going to actually, again, take a look at some Tom Hanks information. We'll look at all of Tom Hanks' movies and the box office revenue globally. So here we go. We're querying that. We have not only the IMDb data, but that virtual graph that goes into our MySQL table and pulls us back out on the fly. Now, what's nice is that these results do not only need to be used here in Stardog Studio. You can build your own apps on top of it, or use very popular analytics tools. We have a native integration with Tableau through a web connector, and I've done exactly that. I've run this here, connected it to that same query that we were just looking at, and I'm pulling data from IMDb for our average IMDb rating here. We have our sentiment score from our unstructured data from the critic reviews, and inside of here we do see a positive correlation. So on average, the higher a critic's review, the higher your IMDb users do as well. You do see some variance, but that is your general positive correlation. Now, what I've also done is tied the revenue value to the size of the cell. Now, again, is not always a perfect correlation, but we see as we go higher and to the right, the more positively reviewed and more desired a movie, oftentimes the more revenue it's going to make. Great. All right. So with that, we've taken a look at different data sources. We've mapped them in. We've done some querying not only in Stardog Studio, but we've also done it in some other tools. Let's take a look at the next step where we start investigating the data, mapping it, and adding in logic and inference to the graph. Now, as a knowledge graph, it is very focused on relationships. Inside our database, we have all this movie-centric data. Each movie has a relatively standard set of relationships. We have a bunch of documents, unstructured text, reviews, scripts, summaries. You have people involved. There's actors, authors, directors, entire long lists of everybody in the credits that would be involved. You have a production company, etc. So how do we take all of this item and add some expertise or add some modeling into it to really get value out of it? A very simple version of logical reasoning could look like this. I have the movies Inferno and Rogue One. Inferno has two actors that we're going to care about for this simple example, Tom Hanks and Felicity Jones. Rogue One has Felicity Jones also as an actor and Gareth Edwards as a director. Now, that's a unidirectional relationship. The movie has an actor. That's how our data is defined. However, we also want to understand the inverse of this. So if Inferno has Tom Hanks as an actor, Tom Hanks is an actor of Inferno. Same with directors. And then we can even roll this up one level higher. Just because somebody's worked on it, or just because somebody's a director or an actor or a grip, it doesn't matter, they've all worked on this movie. We can roll this up to a property called worked on. Now what we can do is say that if anybody who's worked on it, no matter their role, we can associate them together and say that they are coworkers. Not only that, you can even go one step further. If two people are coworkers, we can take one further jump and do the LinkedIn style connection and say Tom Hanks is connected to Gareth Edwards via Felicity Jones. Now, the important piece here is that we are connecting nodes that were otherwise unconnected. Tom Hanks originally in the data has absolutely zero connection to Felicity Jones or zero connection to Gareth Edwards. This is basically our digital SME building in their knowledge and understanding of these relationships into the graph itself. This is something that's very easy for a human to do. We can look at the data and make these inference jumps. However, for a computer to do this via software, they often need to be very explicitly defined. Now let's take a look at exactly what that would look like. So again, I have a few different queries. So I have our Tom Hanks coworkers. Now, if I have my reasoning turned off, I'll just run this query and we see we get no results because there is absolutely no connection between, by the way, that node is Tom Hanks, and his coworkers. Turn reasoning on and we're able to see every single coworker in our data set that Tom Hanks has worked with, and I also pulled back the movie that he worked with them in. So let's pull this a little bit further. We see each of these pieces, Angels and Demons. We have a few here, including Gregor, The Hologram for a King, and A League of Their Own. We can see who Tom Hanks works with in each of those scenarios. Now, again, what's really nice, we have a very simple query, and that logic is now baked into the graph itself. Now, not only can we define those relationships, we can also start including things like business logic, extending our data model to include other components. So a good example with this would be something like, maybe, again, this is a very simplistic example. I want to look at every new action movie and understand who acted in the most films. So this is what our query would look like. We have genre, we want to be action. We're taking our published date, greater than 2010. Now, if you have worked in like SQL databases and been running queries, you probably run into this type of scenario all the time. But essentially what we're doing, and again, this is a simple use case, we have baked business logic into the query itself. We've essentially hard-coded the definition of what is a new action movie. It has genre action, and the date is later than 2010. Over time, if that definition evolves or changes, we have to find every instance of this query and make sure it's updated appropriately. This logic really should not live here. We should like to be able to extract it, put it into the same set of rules. So we have one place as the query to go pull this back, and another place defines that definition of what a new action movie is. So we've actually done just that. So let's take a look at what that looked like. I actually have one of our files here where I have some of those relationships we defined before as far as actors, directors, co-worker relationships. But I'm adding a few others here as well. So say if a movie, I'm basically pulling out the movie, adding this as I'm pulling the year out to add this as a new property. So now instead of just a specific release date, we have a year item. We're going to make a definition of what we call a new movie. Now, in my case, I'm saying everything after 2010. My data is a little bit old. We could do this as a sliding date. Anywhere you want to define this, but this is what defines now a new movie. We define an action movie as action genre, as a genre equal to action. Now, well, that seems pretty simple for this scenario. Maybe over time this changes. Maybe there's other genres or other subcategories you want to make sure they're included. You don't have to go back and modify every single query. We're defining it here. Now, if something is an action movie and it's new, we're going to say it is a new action movie. Great. So let's take a look in our query what this would look like. Typing on the fly is not the best, so I'm actually going to again use one of our saved queries. Instead of defining it in the query itself, we're saying where a movie is a new action movie, pull this back and count up how many movies what are the most prolific new action movie actors. Now we see Jason Statham with 13 from our results from before. Click on execute and we get those same exact results with a much simpler query, and we've now decoupled business logic from the queries themselves. All right. So let's wrap this up. Taking a look back at what we covered, we've pulled data from multiple different data sources, different formats. We've had structured data in IMDb, Netflix, and Wikidata. We've joined this with unstructured text that we're pulling from critic reviews. And then we've also included data that doesn't exist in Stardog. The bookings data that we are looking at, the revenue, still remains inside of my MySQL database, can be updated anytime with whatever applications are updating it, but still are being used to enrich our knowledge graph, so that every single time that we access a piece of data, we understand what it means within the context of the rest of the organization and pull in any related piece of information very, very quickly. All right, and with that, we're going to open it up to Q&A. Make sure you put your items up into the question bar, and we'll do our best to answer. Okay, so let's wrap this up.
Great. I mean, thank you very much for that in-depth look at Stardog. So now with the remaining time we have today, we're going to dive into the Q&A session. The first question is, what is the mechanism that you used for the definition of new action movie? Just the code was a bit tricky to follow there. So good question. So the if-then style syntax that you saw there on the screen, those are called Stardog rules. They're obviously very simple if-then style rules, and those can be added to the knowledge graph like any other data, and Stardog will automatically see that when you commit that transaction and add it to your data model. So as soon as that transaction is complete, it's available for use in queries. I have a couple of related questions here. Wondering how Stardog compares with Neo4j and OrientDB, and the difference between a knowledge graph and a graph database, of which Neo4j and OrientDB are good examples of that. So we'll kind of tackle both of those at the same time. Thanks for those. Those are good questions. I think what you have to keep in mind about plain graph databases like a Neo or an Orient, which are very good systems, but they're very point use focused for kind of very specific graph problems. If you're trying to do something canonically graphy like PageRank or betweenness or clustering, a kind of native simple graph system like that can be a very good fit. But because they lack the features provided in the knowledge toolkit, they really end up being graph-shaped data silos. So you're kind of further compounding the challenges of data silos within the enterprise. But so those are good systems, and Stardog's very happy to make them part of the wider enterprise knowledge graph, so you can use them when appropriate, but still be able to unlock the data that they have within those graph-shaped silos and make them part of the knowledge graph. Next question is, can you handle non-text documents? So absolutely. Out of the box, Stardog comes with support for just textual documents using our system called Bytes. That support is based around NLP, OpenNLP. But NLP and generally unstructured content processing is very use case specific. What's good for certain types of images won't be good for others. What's good for Fiserv documents won't be great for healthcare related documents. So the Bytes pipeline makes it very easy to plug in different NLP packages and different unstructured content processing systems. So if your use case requires the processing of text or video or audio or all of the above, it's very easy to plug those things into the knowledge graph. Next question is, we saw there are Tableau connections. Are there any Qlik connections as well? Currently support is only for Tableau, but we're hoping to add support for Qlik and Power BI. Those are both on our roadmap. Next question is, how do you support data lakes? It's a great question. A lot of people are anxious to get value out of their data lakes after they've devolved into data swamps. So any data lakes for which you've enabled or kind of exposed Hive or Impala access to the data in there, Stardog is able to take advantage of that and bring those right into the knowledge graph and query them like any other upstream source. Next is, are Stardog rules compliant to a standard? The answer to that is yes. The semantics it respects are the semantics of Swirl. There's no human-friendly way of writing Swirl rules, so we came up with Stardog rule syntax as an easy way to author rules in Stardog. And last question here, what kind of NLP did you use for the movie sentiment scores? Yeah, I think the second half of this question I had already answered. Does Stardog have an integrated library plug into any NLP? We used IBM's Open Alchemy for the movie sentiment scores, and we did some entity extraction from those using a combination of our default capabilities based on OpenNLP and the OpenCalais framework. And that's all the time we have today. There's a couple questions we did not get to. For that, I apologize, but we will reach out to those folks directly to make sure they get their questions answered. I appreciate everyone's time today. Thank you for coming. We look forward to working with all of you.
Sounds good. Thank you guys very much. Also, if you have any questions, please feel free to contact us, and we can help you with any questions that you had that didn't get answered or anything that comes up over time. All right, take care, guys. Thank you.